Hello, Mr. Z here with you. We're going to go ahead and cover lesson 1.5. The first video will be talking about writing polynomials, and the second one will be more specifically sketching polynomials. So writing polynomials. If x minus c is a solution to the polynomial, then x minus c is a factor of the polynomial. So in this case, we have a lead coefficient of 2, and the zeros are at x equals 0, x equals 2, and x equals negative 1. Well, that tells me that x minus 0 will be a factor, x minus 2 will be a factor, and x plus 1 will be a factor. And we have to know that the lead coefficient will be 2. So I'm going to go ahead and get that lead coefficient, multiply this by 2, set it equal to 0, so that then that tells me, yes, x equals 0, x equals 2, and x equals negative 1 will all be factors of this. And I'm going to go ahead and start multiplying these out. This x minus 0 I can think of as x, so really the first two factors there, 2 and x, I can write as 2x. X minus 1, x plus 1, I'm going to go ahead and FOIL those and get x squared minus 2x plus x gives me a minus x. Negative 2 times plus 1 gives me a minus 2. And that should equal 0. The next part, now let's go ahead and distribute that to get it truly in standard form. And I get 2x to the third minus 2x squared minus 4x equals 0. And right there is a polynomial in standard form that has a lead coefficient of 2 and has zeros at x minus 1, x minus 2, and x plus 1. So that helps us find something that has simple roots. As far as more complex roots, if we go ahead and look at that situation, if an imaginary number is a root, its conjugate must also be a root. So in this next example, write the polynomial in standard form with roots of x equals 3 and x equals 1 minus 2i. I'm going to do this. There may be some shortcuts. It's been a while since I did this, but I believe this would be the easiest thing to do, is say x equals 3 is going to have x minus 3 as a root, or as a factor. You also have x minus this complex root, 1 minus 2i. I'm going to say 1 minus 2i. And then I also have its conjugate. So I'm going to say x minus 1 plus 2i. That's going to equal 0. Now things get a little complicated, but let's work with this. We have this stuff. When we multiply it out, these i's obviously are going to go away. So I'm going to go ahead and multiply the two of these together. But before I do that, I'm going to think of it as x minus 1 plus 2i and x minus 1 minus 2i. And I still have this x minus 3 going along with it. Now when I do go ahead and factor through, or not factor, multiply out, I'm going to multiply x times each one of the next one. So I'm multiplying this times these things, and I get x squared minus x minus 2ix. Multiply it through by the negative 1, and I'm going to go ahead and get minus x plus 1 plus 2i. And then multiply by the plus 2i, I get plus 2ix minus 2i positive times a negative is a negative 4i squared, a minus 4i squared. And that should all equal 0. And remember, we still have this x minus 3 coming along. I don't want to forget it, and we'll take care of that in a minute because we want it in standard form. But in this case, I have a minus 2ix and a plus 2ix, those will cancel. I have a plus 2i and a minus 2i, those will cancel. I have a negative, well, let's go ahead and get these in. I have x minus 3, x squared, minus x, and minus x gives me minus 2x. And then this 1, and this minus 4i squared. Well, remember, I squared is negative 1, so that's minus 4 times negative 1, which is really plus 4. So I have a plus 4 and a plus 1, it's plus 5. And that all equals 0. And now I can go ahead and multiply through by x. So when I do that, I multiply it through by x, I get x cubed minus 2x squared plus 5x minus 3x squared minus, oh, actually plus 6x minus 3 times plus 5 minus 15. That equals 0. And remember, that is all. I've gotten everything multiplied out. Now to get a final answer in standard form, I'm going to have x cubed. Let me go ahead and do this. This is nice on let me rotate that up. Okay, now I go ahead and I say x cubed minus 2x squared minus 3x squared is minus 5x squared plus 5x plus 6x is plus 11x minus 15 equals 0. And that's my final answer. That's standard form. It has factors of x minus 3, x minus I minus 2i, x minus I plus 2i. So you have to know what the conjugate is. You go ahead and multiply that out. Again, there may be some shortcuts to that, but this is, I'll stand by this as my answer. And that's the polynomial with those 3 roots. Imaginary, its conjugate, and the x equals 3 as another root. So, graphing to equation. Find all zeros in their multiplicity. Write the polynomial in factored form. Solve the leading coefficient A. Plug in point x and y. Solve for A algebraically. So I'm going to show you this. I'm actually going to, when I do this, keep in mind the multiplicities. I can tell how they cross or touch the x-axis. If they pass through it, p equals 1. The multiplicity is 1. Multiplicity is 2. It's going to touch it. It's going to bounce off it. It could bounce off it from the top like this one is, or it could bounce off from the bottom. But if it bounces off the x-axis, it's got a multiplicity of 2. It's definitely even. We can comment on that. And then 0 with multiplicity of 3 would go ahead and sort of snake through. And that's as simple as we're going to get. I mean, that's how we're going to go ahead and address this. So in this case, find the equation of the polynomial in this form. So in this case, I know I have a y-intercept here at, I know I have here at -2, here at 0, and here at 1, 2, 3. I know I have those zeros. This multiplicity of this 0 is bouncing off of it, so it's going to give me an x plus 2 as a root, and it's actually bouncing off of it, so it's going to be a multiplicity of 2. I'm going to use a factor of 2. This one, x minus 0, has I'm going to go ahead and put that out here as x minus 0, and it has a multiplicity of 1. And then my other one, again, bounces off of it, so it's going to be x minus 3 is the 0, and it has a multiplicity of 2. Now, with that in mind, I'm going to go ahead and set, this is going to be equal to 0. It's going to have a lead coefficient. I'm going to put my lead coefficient out there of a. So if I simplify this, this is ax times x plus 2 squared times x minus 3 squared equals 0. With that in mind, I need to go ahead and still figure out my a. I still want to figure out my a. And it said write an equation in Polynomial. So I'm not having to write this in standard form. Not concerned about that. But I do need to figure out my a. And to figure that out, I decided that I was going to go ahead and use this at -1 and positive. And I wrote it as, I really did try it, just randomly estimate that, and I got 1.6. That was a little more than 1.5. It actually works out really nice. And then when I checked it, in Desmos, it definitely agreed with me. So -1, 1.6 is going to be the point I'm going to check. So when I do that, I go ahead and I say -1. So I'm plugging in -1, -1 here, -1 here, -1 here, and here, this is where it gets a little tricky. This was me making my polynomial. I'm going to go ahead and use that. Really, what I was thinking of these are really log. So in this case, this is a two-dimensional picture, and this is going to be 1.6. So let's go ahead and simplify this. We get -a, -1 plus 2 is 1, -1 minus 3 is -4, squared equals 1.6. Now remember, this is 1, this is 16, so it's a -16a over here on the left. I get 1.6. And if I divide by -16 to get the a by itself, that gives me a equals a -1/10. And once I have that -1/10 for a, I can go ahead and write that equation as, going back to what I originally started with, I'm going to go ahead and say a's -1/10, x minus 0 is x, and then I have a x plus 2 factor squared. I have an x minus 3 factor squared, and that equals y. If I'm looking at the graph, find the equation of the polynomial in the factored form. And that is what I have as far as what my polynomial would look like. Y equals -1/10 x times the quantity x plus 2 squared times the quantity x minus 3 squared. And that's going to be for it for now. That's a polynomial. Now, the actual expression that we're looking for when we do this would be this portion only. If we want to represent the graph, it would be equal to y. If we want to represent the zeros, looking for a solution set, we'd set it equal to 0. So that would be us writing the polynomial. And next, our next steps we'll be sketching a polynomial, and I'll be making that video here just in a minute. But that's what I have for you for writing polynomials. Thank you very much.